runs AS58280. In the past, he founded an ISP and wireless ISP in Italy. Worked at the RIPE NCC as a trainer and as the IPv6 program manager, and at the Internet Society, where we work together. And he's involved in numerous program committees and helps run a couple of internet exchanges. And he's based in Zurich, Switzerland.
So good, thank you. Good morning, everyone. I'm here to, let me see if I can get slides. But before I start, there was a positive message at the end of the previous talk. I don't want you to misunderstand what I'm going to say during my presentation. I'm actually in favor of RPKI. It's just that there is a detail that I'm exposing here of things that some people do that we might want to correct. So the title is a little different from what you see on the program. So the title is, how much RPKI do you want in your BGP? Why? We'll see it in a moment. But Amrish already introduced me. I'm involved in a few things. The one he didn't mention is that for some case or fate, I'm behind the Zanok Discuss group on Telegram, and together with Ed and other people. There's a funny story behind that, behind why that happened, but I'm not going to tell it now. It's for beers later tonight or whenever we have time. So for the breaks. So come see me in the breaks if you want to know the story behind that. Now, what is this talk about? This talk is about a small problem that me and a couple of other people have found on BGP and communities and RPKI, and at the end of the talk we are proposing a solution already. So there is work that is being done to correct the issue. But before we start, an important disclaimer. This time it is not DNS. You know, I left out that acronym. This time it is not about DNS. DNS is not guilty. So let's focus on what we need to see today. So there was an introduction to RPKI in the previous talk. I will focus on some slightly different parts of it. So RPKI is divided into two parts. There's a signature part and there's a validation part, and they're totally separate. You could be signing, you could be creating your ROAs without validating, and on the other hand, you could be validating without creating your ROAs. And believe it or not, there are organizations who are in that space. So we have ROAs that are objects that are like route objects, route and route 6 objects. I like to call them route objects on steroids because they have a little bit more information. That's the max length. I would like to tell you that it was named after me, but no, it's not. It wasn't. I didn't participate in designing this. So the structure is exactly the same as a route object. So we have an origin AS, we have a prefix, and then we have a max length. And there's a long discussion about max length not being, well, there are suggestions for not using max length, but that's outside of the scope of this talk. So ROAs are growing. This is an image from the percentage of address space, and I'm sorry the yellow you can't see for IPv6, but this is the case of South Africa, and as you can see, the number of ROAs is increasing. That is good, but related to the problem that I'm going to talk to you about in a moment, this can be a bigger and bigger issue, because the more people create ROAs, the more there can be noise. So when someone creates a ROA, the ROA gets into a database that's run by the 5 RIRs, and then there are software called relying party. There's Routinator, there's RPKI client. They download them, and then they provide them to the routers. And together with the BGP updates, ROAs on one side, BGP updates on the other, and this is the key. They help routers make better routing decisions because they were adding another piece of data. As was explained in the previous presentation, this is where things can go wrong in a way. So there's a decisional tree you have to follow. And there are two parts. One is the ROA validation. ROA can be valid or invalid by itself. Invalid if the certificate has expired, if the signature on it has expired, and so on. But we will not focus on that. We'll focus on the BGP validation part. A BGP update can be valid, not found, or invalid according to RPKI. And then if things are configured well, we should be discarding all the invalid ones. But what do we do with the valid and not found? We have found that some people use communities. What are communities? Communities are a way to tag BGP updates. You have a BGP update, you add a community, you give it an additional meaning. There are small normal communities, and there are large communities, which came because the communities as they were designed, they didn't take into consideration that the size of autonomous system numbers might grow in the future. So we have large communities which not only account for 32-bit ASNs, but account for even more address space to give any route even more meaning. So what happens when we take RPKI and we take communities and we start mixing them? We have found that some operators do this. Some operators tag their BGP announcements with communities which tell us the validation state of that route. And this validation state gets propagated to everyone. So if I were to look into something that is far away from that operator, because communities are I actually wrote it in the community. Communities get propagated across the whole internet. I could understand how an operator hundreds of kilometers away or even thousands of kilometers away have validated that prefix. Now, this can be useful. Maybe I can think of usefulness in this. But there is also a drawback to it. What happens if one of these operators loses all of the RPKI validators they have? So there's about 300,000 routes that would change state, and thus bring 300,000 BGP updates to just change the fact that there is an additional community or the removal of the community. So we've seen this behavior, and it happened about a year ago, where we heard it first, actually March last year, and we decided to do some investigations. So we figured out that there is outdated documentation. There is one book from Juniper that gives the recommendation to tag with communities all your RPKI validation state. The same book still recommends using the RIPE-NCC RPKI validator, which was abandoned more than 3 years ago. The good thing is that last week I was able to talk to, actually, a very good friend of mine is the author of the book. So I talked to him and promised I would help updating that book. So this is one part where there is work already being done to fix this problem. But it is difficult to signal BGP validation state in RPKI. So I started looking. This is my initial list of targets. Can I see these communities somewhere in BGP updates across the world? So there's one of them that I signed that I was hoping not to see. the invalid, which mean if I were to see it somewhere on the internet, it would mean that someone was propagating invalid routes, but luckily I didn't see any of that. And you can see that I took one dump from the 27th of October 2023 at 10 in the evening, and I looked at what I could see. Do I see any tags of this in route views, or even in, I tried also the same in RIS, and I did see that. I didn't see anything from 1299. That is one example that I'm giving you, route views 3, that's one route collector. But if I moved to route views 6, I would actually see entries from 1299. So we established something. We do see these communities in the wild. So what's the next step? The next step was, okay, since we see them, how many updates in BGP carry these communities on a daily basis? So I took a period of 24 hours, and I connected to RIPE-RIS. I used RIS Live, wrote a script that whenever it would see one of these communities would increase a counter, and then every hour I would dump this data. So how many do we see, and how much is the percentage compared to the total BGP updates we see on the internet on a daily basis? And you can see that there is always a margin, a low margin. It's about 10 to 16, 17% of BGP updates that come from 2 operators in the world that carry these specific communities. This is for IPv6, and we can see similar trend for IPv4. So at this point, we've established we see these communities in BGP updates. Now, the next step was to set up a test prefix. I'm lucky enough to have a spare /29 IPv6. So what I did was I built a script that at the same time would update the ROA, create it, and delete it. So my BGP validation state would change every 6 hours, and then check every single BGP update seen by RIPE-RIS for that specific prefix. So what do I see in there? And actually, I did see that there are some operators that do, some more operators than the ones we initially saw, that actually do this tagging, and they explicitly tell everyone. I put an example that is Coloclu. Coloclu is a not-for-profit in the Netherlands for geeks by geeks. So if you want to have your own server in a colocation, and you don't want to pay the normal colocation prices, you can go to Coloclu. And Coloclu is a team of people who work at different ISPs, different networks, or just enthusiasts. And Coloclu has rack space, a networking team, a colocation team. And Coloclu does this tagging of, there is an explanation here that says, well, with this, I think it's 102, I remember, because I can't read it actually on the screen. They tag if something has validated RPKI. So as you can see, anytime I would update my ROA, there were 2 messages, one for the one that contained that community, and one that didn't contain it. So every time I changed my state, there would be at least a little bit of noise from Coloclu. And there were 3 or 4 other ISPs, other networks that I could see with a similar behavior. The difference between Coloclu and the others is that Coloclu has documented it, so I can tell you for sure why. Other networks don't have a clearly documented policy. So that is the the issue when doing this kind of research is that you depend on the documentation from the other side. But I can tell you for sure that there is a bunch of operators doing this tagging. So what is the problem here? The problem is that if everybody were to start doing the same, we would have a lot more noise in BGP. Consider that daily you have the creation or the deletion of a few hundred to thousands of ROAs, which then trickle down with this mechanism into BGP updates. And they create more load for your routers, they create more load for the global internet, and, well, energy consumption goes up and so on and so on. So we do have a problem, and we also have a suggestion. So there is a BCOP draft, Best Current Operational Practice draft, that we have submitted to the ITF. You can go and have a look and check what it says. It basically says don't do that unless you have a really good reason for it. And this is basically it. Then I have some future work that I intend to do here. First of all, RIS Live, the basic software doesn't support large communities, so I couldn't look into that. Between when I wrote the, so this presentation is based on an article I wrote for RIPE Labs. Between when I wrote the article and now, and I have actually built a very tiny BGP message parser so that I can look into large communities coming from RIS Live. So that will help. The problem is, as I said, this is all a manual effort because you do see changes, you do see things that are related to your prefix changes, but you have to manually go and look for documentation in RPSL or on the operator's website and so on. So it requires a lot of time. And that is the biggest issue there. So with this, I'm finished, and I hope I gave you a positive message in a way. RPKI is good. Certain things related to RPKI, we're still learning about them. And this was good practice when people started with RPKI. Now that there are more and more ROAs, more and more operators doing validation, it's less likely to be nice. So thank you. Now I have questions.
Thank you, Max. Do we have questions?
Don't be shy.
If not, I have one for you. So what do you think is the reason that people are actually using that mechanism instead of something else?
I think, as I mentioned, one could be because just it was documented as a best practice. There is a book from Juniper that recommends it. Actually, the book, the PDF has been fixed. The website has been not fixed. So on the website, you still see all the recommendations. The second could be, if I am an operator and I am a transit for other networks, I could tell the other networks, okay, I'm doing your validation, and I'm telling you why. And then you can just see it in my communities. Although I fail to see the value for that, because if you're already filtering the invalids for me, I don't see what else this could bring. But there might be something I'm not considering right now about it. Thank you very much. In any case.
So a quick announcement, we have the peering personnel next. So if you want to present your AS number, please send your slide to preso, P-R-E-S-O, @nog.net.za, and you can come up to stage. Yes, it's going to happen after every session. Great. Our next speaker is Ivan Potapov. Ivan, please come on stage. So a quick